The video, we just reviewed a lot of what's in the notes on the board, and almost everything was something that's in this lesson that they knew. So we're going to go pretty quickly through the notes. Should be review. Are you guys good? All right, so slope you told me was rise over run. You told me the equation for the slope, and that slope was m. One thing we didn't talk about is that slope is the steepness of the line. So that's what the slope is giving you. We're also going to talk about slope as a rate of change. As an application problem, we're going to talk about rate of change. So in this little chart in your notes is everything we wrote on the board. The rise is going to be the difference in the y values. The run is going to be the difference in the x values. And so Candy gave us that equation where difference means subtract the y's and difference means subtract the x's. And then slope formula is right here. And again, it gives us that ratio of rise to run, which we wrote on the board. Everybody okay with that? Sometimes they're going to give you 2 points, and you may have to graph them. And so when you graph them, you can just simply count the rise and count the run. Make sure you put rise on top, run on bottom. That's the most common mistake I'll see with slope in geometry. So be really careful you don't flip those. If you go down, what does that do to your slope? Negative. If you go left, negative. And if you end up with a negative over a negative, that becomes a positive. So be really careful. You can go either direction from the 2 points. You could go down and then left, but if you do, that's a negative over a negative, and so the line is still positive. And so if it's going up from left to right, your slope should be positive. So definitely you can use your graph. If you have a graph, make sure that all of your slopes are reduced completely. Don't write your answers as 6/4. Reduce those down. But don't write them as mixed numbers. It's not helpful to have a slope of 1.5 because your goal for slope is to use it to graph your line. So you need to know how far do I rise and how far do I run. So as a fraction, improper is the better way to leave your slopes. Does that make sense? Okay, but always keep your slopes reduced for me. Okay. So if they give you a graph, for example, like this, then you can just count on your graph. This one says use the slope formula to determine the slope of each line, and then they just listed AB. We're actually going to talk about several of the lines. But let's start with AB. What kind of line is AB? Horizontal. So what should its slope always be? 0. Try to memorize that to make your life easier. If you forget, though, you can write it using your formula, rise over run. How far do you rise from A to B? From A to B, how far do you go up or down? 0. How far do you run left or right? 5. So from A to B, we go +5. That means 0 divided by 5 is 0. And so if you forget, you can plug it in if you get confused which one's which. But I want your final answer to be 0. Okay, so look at line AB. What kind of line is AB? Vertical. So what should its slope be? Undefined. Again, you could write it as rise over run with actual numbers, but you're going to end up with a number over 0. And if you type that in on your calculator, it's going to tell you error, and that'll remind you it's undefined. Is everybody clear there? Okay, let's do one of the diagonal lines. So let's do AC. First of all, just looking at the graph, should that have a positive slope or a negative slope? Negative. And since it's on a graph, we can just count rise and run. So going from A to C or C to A, it doesn't matter. How far do we rise? Careful, I'm hearing 4, 5, and 6. Don't count where you start. 1, 2, 3, 4, 5. We're not going all the way down to point D. We're trying to get to C. So we're going down 5, which means the slope would be -5 because we went down. And then we're going to go what direction? Right. How far? 6. And is that going to be a +6 or a -6? Positive because we went to the right. So my slope would be -5/6. Does that make sense? Okay. So I expect that you should be able to calculate slope by looking at a graph. Just be really careful that you do the y's on top and the x's on bottom. But sometimes you don't want to have to create a graph. And this slide I just skipped, we already talked about. If you are dividing by 0, your slope is undefined. Okay? All right, so sometimes you don't want to make a graph. You may have some crazy numbers and you don't want to graph these really large numbers or these crazy fractions. So instead of making a graph and counting rise over run, although you will be allowed to do that when you need to, we want to try using our slope formula to save us from having to graph it if there's no reason to graph. So slope formula, again, Candy reminded us, all we do is subtract the y's on top, subtract the x's on bottom. So slope equals, does it matter which y value I start with? No, but just be consistent. If I start with -1 over here for the y, I have to start with what for the x? 2. I can't come back over here and use this point. So where do you guys want to start? Which y value? Okay, I heard let's do -1. So I'm going to start here. This is going to be my y2, which means x, this number 2 is what? x2. That means over here, 3 becomes x1 and 1 becomes y1. So if that helps you thinking about plugging it into your formula. So then we're going to plug in -1. The formula is subtracting the y, so it's -1 minus, and then what is our other y value? 1. What will I have on the bottom? Good. What is -1 minus 1? And 2 minus 3. And a negative divided by a negative is a, so this is a positive 2. You can write it as 2 over 1. I won't count off for that, but you can also just put it as 2 because that is a whole number. Questions there? All right. We already talked about this chart. Positive slope goes up from left to right, negative down, 0 is horizontal, undefined is vertical. The only thing we didn't talk about that I already mentioned just a moment ago is rate of change. The reason you calculate slope is not so that you can sit in math class and graph a line. Slope has real life application. Slope, for one example, could determine the steepness of an actual road. They may talk about the road and its percent grade, which you'll talk about later in this class. Percent grade determines that steepness of that road. There'll be danger signs that say it has a certain percent grade, letting drivers know, hey, this is going to be a really steep hill going down or going up, to beware. Or it may calculate the rate of change of a situation. For example, in real life, when we're driving, we have a rate of change, miles per hour. So for however much time has passed, we're going to go a certain distance. That distance divided by time gives us a rate of change. So if you're going 30 miles per hour, you're going 30 miles in every hour. Does that make sense? Okay, and that's a slope. That's what that's calculating. So anytime you have a word problem that's talking about a rate of change, it's talking about slope. Okay, so here's our first example. I tried to save time today and gave you a lot of the graphs, but on the homework it's going to say graph the line, and it's not going to give you a graph. So I'm going to ask that you make sure you pay close attention right here, since it's already graphed for you, about what I will be picky about when you graph the line. Okay, everybody with me? So this picture's on your paper. Let's read this problem. It says, Justin is driving home to his college dorm. At 4 p.m., he is 260 miles from home. At 7 o'clock, he's 455 miles from home. Graph the line that represents Justin's distance from home at a given time. Find and interpret the slope of the line. So first of all, when you go to your graph, I expect you to label your axes as which one stands for what variable and what is it representing in your problem. So if we have an X and a Y, this is something we didn't write on the board that we may want to add over here to our review notes. Which variable is our independent variable? That means it happens no matter what all the time. Is it X or Y? X is independent. So on a graph, you always put the independent topic, whatever that is, on the x-axis. And then you put the dependent information on the y-axis. So if we're talking about, what two concepts are we talking about here? Time and distance. So which one occurs no matter what? Time. So our time is going to be independent. It should go on which axis? X. So on your graph, I expect you to label down here, time, and then you're going to tell me what your units are. What are we measuring our time in? Hours. And then you're going to come over to your y-axis and you're going to tell me, what is this talking about? Okay, and so miles is representing what topic? Distance. So you'll put distance and then it's measured in miles. So you always want to label a graph that deals with an application problem so that it makes sense. You can read that graph and understand, what's this information even telling me? Okay, from there, it says at 4 o'clock he's 260 miles from home. So which one of those two numbers represents the x value? 4 o'clock. So that's where they got the 4, 260. 4 hours, 260 miles. And then the other coordinate we would have would be at 7 o'clock, he's 455 miles from home. And so then on your homework, you would graph those 2 points and connect the dots. But how are you going to know where to graph those points? What are you going to have to do to your piece of graph paper? You have to label your what? Your numbers. You're going to have to label your scale. What I don't want you to do is have this piece of graph paper and cram all your graph up in this little corner if you don't need to use this. So what would be a good place to actually start my origin instead of right here? All the way to the left and the bottom. So you could take this graph, if we know that we're not going to have any negative values, we could shift our origin all the way over here, which gives us our entire graph to work with. Does that make sense? Why wouldn't we have any negative numbers here? Okay, I've shifted my origin, but why can I shift it? Why don't I have any negative numbers? Okay, you can't go a negative number of miles, and you can't have a negative time. And so we only need positive numbers. So I'm going to shift it over here instead of cramming it up in this corner. And then I don't want your whole graph crammed right here. Okay, spread it out and fill your graph. So think about, how many marks do I have? And what's the highest number I need to get to? And try to divide that out so that you can space this out on your whole graph. Does that make sense? So this, what's the highest number we have to get to on the y-axis? 455, right? So if I'm looking at all of this space on a normal piece of graph paper, what do you think would be a good unit to go by? Say it again, Raina. Okay, I could go by hundreds. That's what they did. But if I have all of these places, if I go by hundreds, I'm only going to need to get to right here. So 50s might be good, or maybe even going by 25s might be good. So I want you to try to spread it out on your graph when you're working these problems. Does that make sense? Okay, but make sure that you look for the highest number to know how high do I have to get, because it may not be, you may not be able to go by 25s if it's too high. Okay, maybe you'll be able to go by 5s or 10s depending on how far you have to go. And then the same thing on the x-axis. What's the highest x value we have to get to? 7. So we could still go by 1s and have plenty of room, right? Everybody agree? So if you change your axis, you have to label it at least a few increments so I know what you're going by. Everybody clear? Okay. So then we would graph those 2 points, connect them with our ruler. Why is there not an arrow down here? Okay, that's where it starts, and we just said we can't have any negative values for distance or time. So instead of graphing a line, you've really graphed a ray. So try to think about your problem. Can you have negative numbers? What should your graph have? And try to create the correct geometry figure that matches that, whether it's a ray or a line or a segment. Any questions there? Okay, so since I provided you with the graph, I wanted to make sure you understood what I expected of you on the homework. So now let's do the next part. Find and interpret the slope of the line. So they want us to find the slope. Would this be a good one for us to just count rise and run? No. Our graph is not detailed enough. Trying to count that would be very very difficult. So we just want to use our coordinates and use our slope formula. So what would go on the top? Okay, so specifically in our ordered pairs, what would I put? Okay, 455 minus 260, what would go on the bottom? And then simplifying, help me out. What's 455 minus 260? Very good, 195. And 7 minus 4, 3. And if you divide that, what do we get? 65. Now be careful, it said find and interpret. When it says interpret, I expect you to write me a sentence explaining what does this mean, 65. So think about the question again. What is 65 telling us? The number of miles per hour that what? Who's he? That Justin drives from home to college. So write a sentence that explains that. Justin is driving 65 miles per hour from home to college. Does that make sense? Any questions? Okay, so those are the harder ones where it's more of an application, but again, just be really careful on your graphs. Do not leave today without graph paper in your binder because you will need some graph paper for your homework, okay? And I don't want you to draw your own graphs. We already talked about this. Parallel lines have the same slope. And even though vertical lines have undefined slopes, they're still parallel to each other. So every vertical line is going to be parallel to another vertical line. This is different than what we said. We said perpendicular lines have opposite reciprocal slopes. It's on the next slide in your notes where they say that. So if you look here, they say that perpendicular lines will have opposite reciprocal slopes. Remember, opposite is where you're talking about the signs. Reciprocal is where you're flipping the fraction. Are we good? Okay. So now we're going to do the next part. And again, I provided you with a graph. Again, I was just trying to save us time, but I want to make sure you can do what I'm asking you to do. So on the homework, it's going to say graph the lines. You're going to grab a sheet of graph paper. You're going to graph the lines. Which lines are we supposed to graph according to this problem? U, V, and X, Y. Be careful. Every year I'll have students who will plot all of these points and then they'll just pick two to connect. It specifically said to connect which two? U and V and X and Y. So don't just pick two to put together. So UV would be connecting these two. XY would be connecting these two. And I am assuming that you can plot a point and connect them with a ruler and draw arrows on the ends. Is that correct? Okay. So that's all the algebra that you should have come here knowing how to do. So now we want to graph them and then we want to use their slopes to determine whether they're parallel, perpendicular, or neither. So we need to calculate the slope of UV and the slope of XY. And what's going to tell me if they're parallel? They have the same slope. What's going to tell me if they're perpendicular? They have opposite reciprocal slopes. And if they're neither one of those, then the answer is neither. Which one of those can we rule out just by looking at the picture? Parallel. Everybody agree that these lines are not parallel? Okay. So we know they're not parallel. Now we're just trying to decide, are they perpendicular or are they neither? Do not look at them and assume that they look like they form a right angle. They may make an 89-degree angle, and that's going to look like 90, and you're going to get it wrong. So be careful. Find their slopes. Is this a good one where we can just count rise over run? So let's just do it that way. So let's go U to V first, this positive slope, U to V. So what is my rise? Okay, I'm going to go from V to U. So positive 3, and then what's my run? 1. So my slope becomes 3 over 1, which is 3. Okay, let's do X to Y. I'm going to go from Y to X. So what's my slope? Down 2. Good. So that's negative 2 over. And since we went to the right, is it positive or negative? Positive. What does negative 2 over 6 reduce to? Negative 1/3. Be very careful. This is not 6 over 2. 6 over 2 is negative 3. If it's 2 over 6, 2 goes into itself once, 2 goes into 6 3 times, so this is negative 1/3. If you use your calculator, does everybody know how to take their calculator and do math to fraction and change it back to a fraction? If not, right now, take your calculator, type in negative 2 divided by 6. Negative 2 divided by 6. It should give you negative 0.333333, right? Now go to math. Math is the key under the green alpha key, and then there should be an option that has an arrow frac. That means change to fraction. So go ahead and hit enter on that, and hit enter. And it nicely gives you what it is in fraction form. So, using your calculator, but don't lose your number sense. Okay, so we should be able to do this without a calculator, but when we're taking a test, we want to make sure we didn't mess up. So that's a great way to check it on your calculator. And when you're taking a timed ACT or PSAT or something like that, who cares if you can do it in your head? Let's do it the fastest way so we don't run out of time. Okay, are we good? Math fraction. Okay, so now look at your slopes. Are they the same? No, we ruled that out already, that they wouldn't be parallel. Jaden? Yes, I would. The only reason I left it like this is because we're comparing them to see, are they opposite reciprocals? So are those opposite reciprocals? One's negative, one's positive, and they are flipped over. Does that make sense? So yes, we could have definitely wrote this as 3, but then we need to recognize that 3 is the same as 3 over 1, so that is 1/3 flipped. And so these two lines are perpendicular. Any questions? All right, that was 3-5. Would you agree that the majority of that was review from Algebra 1? Okay, so now we're going to review 3-6. Take your piece of paper. Let's see what you know from 3-6. And this is a little bit harder part. But again, hopefully you still know a lot of it. So tell me what you know about equations of lines. Equations of lines. Do you know any forms of equations of lines? Slope-intercept form. So again, write this with me on your little review sheet that we started out with. Slope-intercept form. What is the slope-intercept form? Very good. Y equals mx plus b. What part of that equation is the slope? M. Just the m, not the x. What part of that equation is the intercept? And what kind of intercept is it? Y-intercept. So B is our Y-intercept. Okay? Do you know any other equations of lines? Okay, have you ever heard of point slope? Okay, point slope form. Do you know what point slope form is? Raise your hand if you have heard of point slope form before. Okay. So point slope form. Anybody know what it is? Okay, I'm going to help you out. You tell me once you start remembering. Y minus, there's no A, there's no B. You're thinking maybe quadratic equations like y equals ax squared plus bx plus c? Maybe, I don't know. Y minus y1, who said that? Kim or Allison? Y minus y1 equals, okay, there is an x minus x1 over here, but we're missing something first. M parentheses x minus x1. Okay. So this is the form that most students have forgotten the most, but I'm going to tell you it is really in mathematics the most useful of the two. A lot of teachers in younger grades will teach y equals mx plus b, and that's what they always want to use. But as you progress in math and the problems get harder and more difficult, and you go into pre-cal and you go into calculus, you're going to want it in point slope form, because the y-intercepts are not going to be pretty numbers. They're going to be these ugly values that are fractions or large numbers, and they're not going to fit on your graph, and they're not helpful at all. What's going to be helpful is just a point on your graph and the slope, because you can plot any point you want and use your slope to get a second point, right? It doesn't have to be the y-intercept. The y-intercept is just one point on your line that you could start with. So point slope is really the most useful form. It's just that in our younger grades, I think our teachers kind of stick with this form more often. All right, so what in this equation is our slope? M. And what is our point? The x1, y1. The y and the x do not change to numbers. They are variables. They are the things that create all the different points on your line. So they represent all the different values of the points on your line. x1, y1 is a specific point on your line. So x1, comma, y1 is your point. Now here's the thing that most students get confused with. The formula has minuses in it. So if this is x minus 2, what is the actual value for x1? It's positive 2. If this is x minus 2, the x minus is part of the formula. The x1 is positive. So when you plug it in, then it'll change the sign. When you pull it out, it's going to change the sign. It's in parentheses, so you've probably been taught in some of your classes what's in parentheses changes sign. But it actually changes sign out here as well, just because it's y minus in the formula. So if this is y plus 2, then it's negative 2. Does that make sense? Because for it to become a plus here, it's got to be y minus from the formula, and then a negative 2 makes that a positive. Okay, and we'll practice when we get to the notes. But y plus 2 means that your y1 must have been a negative 2. So when you pick out your point, you're going to change the signs. Change them when you pick it out. Change them when you plug them in. Okay? Very important. Be very, very careful. Okay. Let's see what else. All right. So talk to me about how horizontal and vertical lines are different and do not fit these molds of point slope and slope intercept. So in other words, if I have a horizontal line on a graph, here's my origin. What's the equation of any horizontal line always going to be? Okay, so the number it passes through right here, what is that point going to be? Okay, it's going to be a number. Well, what's it going to represent on the graph? It's crossing this axis, so what do we call the point that y-intercept? So this is going to be my y-intercept, which we call letter what? B. And so the ordered pair for that would be what? What's the x value? 0. What's the y value? B. Okay, so you need to add that because that you're kind of shaky with. The x, I'm going to put it here, x-intercept, or no, I'm sorry, y-intercept is what we were talking about. Y-intercept is always going to be 0, comma, b. Everybody agree with that? So the y-intercept, the x value is going to be 0 and it's crossing the y-axis at b, whatever that number is. For any graph, the y-intercept is always 0, comma, b. Any graph. If I graph a diagonal line, this point right here is going to be at 0, comma, b, whatever that value is. The reason we're talking about it for horizontal lines is because we're trying to figure out what the equation of this black line is. For any horizontal line, what's the equation of that line going to be? What did we just say was true about its slope? 0. So if I'm over here plugging in 0, what's 0 times x? 0. So y is going to equal 0 plus b. And what's 0 plus b? B. So the equation of any horizontal line should always be y equals b. This is the equation of every horizontal line. If you forget, you can plug in 0 for m and do 0 times x is 0 and 0 plus b is whatever and get your equation. But you could just really quickly write y equals and whatever that y number is, and you would be done. Okay, so if this is y equals b, because the y value never changes, what would the equation of a vertical line be? X equals is correct because what's not changing on a vertical line? The x. The y is constantly changing. I'm going to draw my axis here for you so you can see. Here's the axis, here's the origin. So here's my vertical line. So it's going to be x equals, but be careful. Let's talk about where it's crossing. Does it ever cross the y-axis? Not unless it's going, it is the y-axis, right? So this point right here crosses the x. What do we call a point that crosses the x-axis? X-intercept. An x-intercept has an ordered pair. What's going to be the y value of an x-intercept? 0. The x value is what's going to go here, and we usually call that a. If we don't have a value, we'll just call it a. So a is going to represent our x-intercept. So right here where you wrote y-intercept is 0b, x-intercept is going to be what? A, comma, 0. Where b represents our y value, a represents our x value. Okay, so back to my equation here. If it's a vertical line, my equation should be x equals what? A. There is no slope. The slope is undefined, so it doesn't fit the mold for these. Does that make sense? Have you heard that before? X equals a number, y equals a number for equations of lines. It's just been a little while, so maybe some of you have some habit. Okay. What else do I have here? Okay, last thing, back to our parallel and perpendicular lines. We said that parallel lines are going to have the same slope, perpendicular lines are going to have opposite reciprocal slope. The only thing we didn't talk about is two lines that have the same slope and the same y-intercept. And this is usually one that most of my students haven't heard before. So they're parallel if they have the same slope. They're perpendicular if they have opposite reciprocal slopes. But to be parallel, they can't have the same y-intercept. Because if they did, they would be intersecting, right? So if they have the same slope and the same y-intercept, does anybody know what they're called? They're called coinciding. Have you heard that before? Okay, coinciding lines. Some say yes, some say no. Write it down either way so you have it. Or some teachers call them coincident lines. Coinciding or coincident. Same slope, same y-intercept, same everything. They land on top of each other when they're graphed. Okay. We're going to do some problems and use all of this. That was your 3-6 information. Let's see how well you can actually write equations using all of this. Did I already pass these out? Stapled. I think these are better. These are all stapled. Stapled. Okay. Oh, sorry. Forgot about Michael back there. Okay. Again, I'm going to go through the notes pretty quick and just hit the examples since we made a very good review on the board. So here's the chart in your notes that has everything in it with point slope form, what that looks like. Slope intercept form, what that looks like. That the equation of a vertical line is x equals a number, which that number is your x-intercept. And the equation of a horizontal line is y equals a number, where that number is your y-intercept. And we talked about how to write those x-intercepts and y-intercepts as ordered pairs. Y-intercept is 0, comma b. X-intercept is a, comma 0. All right, so let's write some equations. Biggest thing you want to be very careful about here is what form they tell you to write it in. If you write it in the wrong form, you won't get any credit because the form is what I'm checking to make sure you know the difference between. So what form is point slope form? Okay. Okay, be careful. I heard two different answers. Okay, be careful. So y minus y1, and I'm going to actually shift over here because this keeps messing up. Y minus y1 equals m times x minus x1. What parts of that equation should have numbers in place of them for my final answer? Y1, m, and x1. Does everybody agree? Okay, so now we read the problem. Write an equation of a line with the slope of 6. Where does that go? M. Okay, and then it passes through the point 3, negative 4. Where does 3 go? Ooh, careful. Excellent. That's another very common mistake I see. Remember, your ordered pairs are always x, comma, y. But your equation starts with the y, so be careful. 3 is going to go in for the x. Negative 4 is going to go in for the y. So it's going to be y minus, and then we're going to plug in a negative 4. So what is minus a negative? Plus. So this becomes y plus 4 equals 6 times x minus 3. You leave it in that form. Somebody last hour said, do we distribute the 6? And I said, no. Remember, your whole goal is to write it in point slope form. If you distribute the 6, you're starting to put it in slope intercept form because you're trying to get all the things combined. They don't want it combined. They want it to where you can see the slope and a point. So that if you wanted to graph it, you could graph it. Does that make sense? If it's in the parentheses, it lies? Yes. I'm pretty sure that's what they taught you. So definitely if it's x minus 3, it's in parentheses, it lies. It's really a positive 3. But you have to be careful because on this one, because the formula's got a minus, it's actually lying outside as well. Okay. Good. All right. Next one is a little harder. Yours shouldn't have this, so ignore that right there. So again, they want us to write an equation of the line. This time they give us 2 points, and they want it in slope-intercept form. What is slope-intercept form? Awesome. So what are the two things in this equation that have to have a number in their place? M and B. So we've got to find slope and the y-intercept. So how am I going to find slope if I know it passes through these 2 points? Good. We're going to use our slope formula, right? All right. So let's do that real quick. Over here to the side. M equals, what am I going to plug in on the top? 2 minus 0 is great. Starting here and going here. So 2 minus 0 then. And 1 minus a negative 1 becomes 1 plus 1. Does that make sense? Okay. And then that simplifies to 2 over 2, which simplifies to 1. So that's going to go in the place of our m. So now I'm going to have y equals 1x plus b. How do I find the y-intercept? Okay, that will only be a good thing to do if the y-intercept turns out to be a nice, pretty whole number. If it's a fraction or it goes off of my graph, that's not going to be a good way to work it. So let's find a way that will work anytime. But that would be a perfect way, Katie, if it's a nice, pretty whole number. Say it again. That has to do with slope. We're trying to find the y-intercept. because that's what Katie said. Can we graph those 2 points and then use them to continue that slope to find B? That will work if our y-intercept is a nice, pretty whole number that fits on our graph. That's not always going to be the case. So what's another way we can find B? Say it again. And how will that help us? We need to solve for B. How would I solve for B? But if I get B by itself, I've still got variables in my equation, so that doesn't help me. I need to find a number for B. Exactly, Katie. What do I need to substitute? Exactly. So remember back in Algebra 1, and think about what you're doing here and see if this makes sense. Everybody with me, because I know I got some who do, but I want to make sure everybody's with me. This is an equation of the line that these points lie on, right? And these are points on this line, so that means that you should be able to substitute these points in for x and y. And if you do, that will help us get the value for B. Doesn't matter which point you plug in. No. So just pick one. Doesn't matter. What do you want to do? Everybody always picks this one. I don't know why. But okay. There's no negatives. It's easy. All right. So 2's going to go in for what? The y. 1 was our slope. What's going to go in for x? 1 plus b. All right, then we just solve for b. So now we have 2 equals, what's 1 times 1? 1 plus b. What do we do? Subtract 1. So b is positive 1. So would it have worked what Katie said about graphing these two and then completing the slope to find the y-intercept? Yes, but I just want you to know that it doesn't always and won't always work out to be a pretty whole number. Is this our answer, b equals 1? No. Our goal was to write an equation of a line. So we have to go back to y equals, very good, 1x plus 1. Because slope was 1 and y-intercept was 1. Very good. Do I need to put a 1 in front of my x? No. You can just put x. And actually, some teachers in Algebra 2 at that point think you should know that you don't need a 1 there, and they actually count off for putting a 1 there. But I'm cool either way, so we're good. No pressure. Okay, let's try another one. The more we practice, the easier it'll be for you guys on your homework. Write the equation of each line in the given form. This time we want to write the equation of a line that has an x-intercept of 3 and a y-intercept of -5. And we want it in what form? Point slope form. Make sure you read your directions carefully and do whatever it says. So point slope form is y minus y1 equals m times x minus x1. All right. What do? Plug in what? So what is my x and what is my y? Oh, be careful. If you plug in 3 for x, okay, hold on just a second. If I plug in 3 and -5, 3 is the y-intercept and 5 is the x-intercept, right? If you plug it in for the x and the y, you're telling me that the point is -5, 3. Is -5, 3 an x-intercept or a y-intercept? No. This is not a point on your line. So what is the, oh, I'm sorry, I wrote it the other way, didn't I? I thought that was backwards. Ignore that for a second. Still same scenario. X-intercept was 3, y-intercept was -5. If you write it like this, you're saying that 3, -5 is my x-intercept and y-intercept. Is that an x-intercept or a y-intercept? No. This is a completely different point. So what is the x-intercept in ordered pair form? So what is our x-intercept if this is 3? 3, 0. What's our y-intercept if it's at -5? 0, -5. The most common mistake I see when it comes to this kind of problem is students saying that there's a point at 3, -5. That is not correct. Be super careful, okay? So what do we need to fill in here in this equation? What are we looking for? What needs to be replaced with a number? Okay, y1, x1, and m. How do we find slope if we have these 2 points? Slope formula. So let's start there. So slope is equal to, what's going to go on top? -5 minus 0. What's going to go on bottom? 0 minus 3. So that becomes what on top? -5. What do we get on the bottom? -5 over -3 becomes +5 over 3. Is everybody with me on how we found slope? Okay, so that needs to go in for the m here. So we're going to have +5/3. What's going to go in for x1, y1? What does x1, y1 represent? It's an ordered pair, which is just a point. And we have how many options for points right now? 2. So you're just going to pick one. Don't put 3 and -5. That's a different point. You're either going to use 3, 0 and write your equation, or you're going to use 0, -5 and write your equation. So there's 2 possible solutions, and you don't have to write them both. You can just write one of them. Okay, so let's say we use 3, 0. So if we use 3, 0, our equation would be y minus 0 equals, so everybody agree with that? This would be our equation. Leave it as y minus 0. Don't simplify it because the whole goal is to be able to pick out your ordered pair point slope. If we use the other one, I'm going to go ahead and write it just so you'll have it in your notes. 0, -5. What would my equation be? Make sure you're with everybody else. Why did they put y plus? Minus a negative. And then x minus the x is 0. Either one of these are solutions. You don't have to put them both. Pick one. Questions so far? No, all slopes always need to be written as improper reduced fractions because the whole goal is to be able to see what is my rise, what is my run. As far as you have to be able to do this kind of question, and you have to know your formulas. So that you need to know for the vocab test because it's going to be on your vocab. If you remember on the vocab review, we had y equals mx plus b and y minus y1 equals m times x minus x1, and you need to know the difference between the two. So you do have to know those 2 different equations and then be able to solve all these different kinds of problems. Yes. Okay. On our notes, try this one on your own. Write the equation of the following line. Sorry. Okay, I want you to check your work up here with me. First of all, slope-intercept form means you should have started with. Okay, you got to know the difference between the two. If you start with the wrong formula, you're not going to get credit. Slope goes where? So now I have 0x plus b equals y. What do I do to find b? 4 goes in for, 6 goes in for y. So we have now 6 equals 0 times 4 plus b. What's 0 times 4? 0. So now we have 6 equals b. Okay, 0 plus b is just b. So that's our b. So our final answer should be, okay, and we could write it like that way, and I would give you credit, but what is 0x? Which means it's what? 0, and 0 plus 6 is 6. So our equation could be simplified down to y equals 6. And remember we said a few minutes ago that every horizontal line has a 0 slope. So this had a 0 slope, and that the equation should be y equals the y value. So if it's passing through the point 4, 6, then it's passing through what y value? 6. So we could have looked at that and said, horizontal line has to be y equals, and the number it goes through on the y-axis is 6. Okay, what if it had said the slope is undefined? The vertical line, so it would be x, and if it was going through this point, what would be the value that the x would cross through? 4, the x value. And you wouldn't have to show any work, you would just put x equals 4. Does that make sense? Jaden? Accept that with no work, yes, because you should be able to do that quickly. Make sure you have that down or in your mind, because you may have a problem on your homework that says you have an undefined slope, and you've got to know undefined means vertical, and vertical doesn't fit the mold, so it's not going to fit one of these methods. It's going to be x equals a number. Okay, are we good? All right. Next thing we're going to do it together, and that's graphing the line. I gave you a sheet of graph paper and asked you to grab a ruler. We're going to graph this line together. What form is it in? Point slope. That means it's giving us a point and the slope. So let's start with, what point is it giving us on the equation? It is not positive 3, negative 4. Negative 2 is not our point. Katie? Close. It's not negative 4, negative 3. Okay, so remember, be very, very careful. This is where every time I have students make mistakes. This is y minus y1 equals m times x minus x1. And if you write that down, you probably won't make a mistake. If you just look at it and try to pick out your point, you'll probably make a mistake. That means x1 is this number when this is a minus, but this is a plus. So what does x1 have to be? Negative, which means you're changing the sign when you pick out your point. The x is negative 4, and the y is positive 3. That's your point, negative 4, comma, positive 3. Now what's our slope? Negative 2. So when we go to our graph, where do we start? Negative 4, positive 3. You have to graph a point before you can use slope. You have to have a place to start. So graph the point, negative 4, 3. Negative 4, 3. Graph that point. And then what do we do to graph another point? Okay, so down 2, and this is negative 2 over 1. So we're going to go down 2 and write 1. And you can do that as many times as you want, or you can take your ruler and connect those dots with your ruler. And when you do, make sure you put arrows on the ends and make sure you go through your graph paper. Don't just make a tiny little bitty line. Okay, so use your ruler, connect those dots, put arrows on the ends. Questions? Okay, flip over to the next page of your notes. We've already talked about this as well. Parallel lines are going to have the same slope, but they will have a different y-intercept. Coinciding lines have the same everything. And if they're not parallel and they're not coinciding, they might be perpendicular, but they might just be intersecting. So you'll have to look at the slopes to decide if they're different, are they opposite reciprocals, or are they just different? Does that make sense? If they're just different, we're going to say intersecting instead of perpendicular. Okay? So on the next part of the notes, it says determine whether the lines are parallel, intersecting, or coinciding. Does it say perpendicular at all? No, so don't give me an answer of perpendicular. You're either going to say parallel, intersecting, or coinciding. To do that, you have to look at what? The slope. So you look at the slopes. Are these the same? No. One of them is positive 3, one of them is negative 3. Are they opposite reciprocals? No. If I take 3 and make it a fraction, that's 3 over what? 1. If I flip it, it should be what? Negative 1 over 3. Is that negative 1 over 3? No. So these are not parallel, and if they don't have the same slope, then they're definitely not coinciding. So they are intersecting. And they're not perpendicular, even though it didn't ask about that. I just wanted to make sure that you realize they were not perpendicular. Okay, what are we going to have to do different before we can make a decision on the last example here on the front page? Say it again. We have to get y by itself. You cannot find your slope unless you have it in y equals mx plus b form. So you have to first find your slope by making sure you have y equals. This one is great. What's my slope? Okay, this one is not great. What do we need to do first? Make sure you divide everything by 6. Don't just pick and choose, or you'll make mistakes. The 6's cancel here. We have y equals, what's negative 2 over 6? Negative 1/3. If you forget, don't forget, you can type that in on your calculator and do that little handy math to fraction, and it'll tell you it's negative 1/3. X plus 2. 12 divided by 6 is 2. Compare their slopes now. Are they the same? Yes, be careful that you don't just go, oh, they're parallel without looking at what? The B, the y-intercepts, because if they have the same slope and the same y-intercept, what are they? Coinciding. But do they have the same y-intercept? No, so these are just parallel. Okay, last example, am I correct? Is our word problem. So let's see if we can do this word problem. Okay, so this whole lesson has been about writing equations of lines. Maybe parallel, maybe perpendicular, but writing equations of lines. So when we look at this problem, we probably are going to need to write an equation of lines. It says Eric is trying to decide between 2 car rental plans. Plan A, Plan B. There's a typo on your notes. This should be 50 cents per mile. Please add that in your chart. The question says, for how many miles will the plans cost the same? So what we need to do is we need to write an equation for each plan. When you look at the 2 things in Plan A, one of them is something per something else. What topic did we talk about today? Slope. Slope is a what? It's a ratio, which is a rate of change. And this is dollars per mile, so it's a rate of change. They're going to pay 35 cents per mile. So this mileage fee represents our slope. An initial fee on a graph starts at time equals what? If it's our initial fee, time equals 0, right? Initial fees, your initial amount you pay at time 0. So if this is our initial fee on our graph, what is this representing? Not necessarily the origin, because my fee is not 0. Where I start, but again, on my graph, it's where the time is 0. So if my initial fee is $100, it's my y-intercept, right? Is that making sense? So this is B. So this is B, this is M. Initial fees are going to be your starting value on your y-axis, and your mileage fee is a rate of change, so it's slope. So let's write an equation for plan A. Plan A is going to be y equals, what's the slope? Careful, slope again, 0.35. So I'm putting this in y equals mx plus b form. So y equals 0.35 what? X plus 100. Okay, let's do the same thing for plan B. What's my equation going to be? All right. Everybody with me on how we got those two equations? Okay, now what does x and y represent? If this is 35 cents per mile, and I'm putting 0.35 times x, what is x representing? Say it again. The number of miles. So x is going to be our number of miles. And if we take 35 cents times the number of miles, that gives us a dollar value, or an amount, plus another $100. All of that put together is y. So what is y calculating? Total cost. And the question said, when will the plans cost the same? So if y is the cost, what do we want to be true about these two y values? We want them to be the same. So what we're trying to figure out is what value for x makes these the same. So what could we do to solve for x? Technically, that would work. We could solve the system and subtract them. Or that would be doing elimination method, and that would be totally fine, Jaden. Or if we want these to be the same, I could take this and put it where? In for y, because we're saying it's the same as y. So we could set them equal to each other because we want the y values to be the same, so we want these two expressions to be the same. So we could just say 0.35x plus 100 is equal to 0.50x plus 85. If we want them to be the same, we want them to be equal to each other. Does that make sense? Okay. So now let's solve. What do you want to do? Subtract the 50, okay? Subtract 0.50x. Subtract 0.50x. What is 0.35 minus 0.5? Negative 0.15x plus 100 equals 85. Now what? Say it again. Take away 100. This is getting low on the board, so I'm going to come over here. So now I have negative 0.15x equals what? Negative 15. What do we do next? Divide by negative 0.15. Negative 0.15. So what is x going to equal? 100 what? What did x represent? Number of miles. So this is 100 miles. So we would say in a sentence, Erica, let's see, for how many miles will the plans cost the same? Erica, actually, let's say will pay the same at $100. 100 miles. Or you could just say the plans will cost the same at 100 miles. Questions? All right, that was a lot today, but hopefully